Hello, I'm Klarenbeek. With our design studio, we focus on experimental research and trying to find unexplored connections between new technologies, local environments, local makers and users. And this, to create both products and apply these new technology in public space projects. So today I'm going to tell about our newest project, which is the mycelium project. And there we use the mycelium, which is actually a fungi, the mushroom, this to bind organic waste. So we 3D print with living material combined with local waste to absorb this waste and create products with a negative footprint. And this all started in Mumbai, India, where I was with a research trip with Droog Design and working with all these locals within these informal settlements. And they collect all these plastics from Mumbai and area and melt them within these buildings. And I felt pretty comfortable being there and working with all these people as they applied the same plastics as we use for our home 3D printers at our studio and all our makers around us. And on the other side, I was inspired by this density of this network, how they collaborated so effectively and efficiently on a very natural way. So we started to think about how can we, what is available for 3D printing and what is there? So on one side we have these oil-based plastics we apply, like these ABSs for 3D printing. And on the other end we have the bioplastics. But both these resources have to come, for the Netherlands, from either the States or Asia. And they both involve intensive production and transportation. And even these bioplastics also involve GMOs and put even more pressure on agriculture. So we thought if we can start with the beginning, like with growing cells, and take out all this transportation and fabrication, and immediately transform it into products or even buildings, then we're able to do everything on spot and locally. So we cooperated with the University of Wageningen and started to build this mobile lab in the public park in Wageningen, the Arboretum, and trying to experiment with local resources over there with open source printers. Collecting straw, wood chips, grinding them, and then 3D printing them. And then we came in contact with the mushroom research group over there. And this brought us a kind of new light on how to bind this matter. So we grind all our waste, and then it's still loose. And by this, using this fungi, it grows all together and it becomes a structural material once you dry it. So here are the samples where we did experiments with either very loose, very dense materials and combinations. So applications are really almost endless, like varying from textiles to architecture. And resulting in this final printing process. So now what we do, we harvest local waste like straw and wood chips. We grind them, and then we inoculate them with our mycelium, our mushrooms. And before it's full grown, we 3D print it, and then we just let it rest. So here you see the process from the beginning where it's still loose and not structural, till 2 weeks later that the material is completely full grown and bind all our waste together. And to do this, we use open source printers and modify them for our needs. And that's why we like this kind of open source community and network, that we are able to use these printers and this software and make them also accessible, but also to hack them and use it for printing local materials. So you see this process where we use a waste product of a Dutch company, which it's a Dutch potato company, and that's the outer shell, and we can print the inner structure. And we can define the inner structure, the density, and finally the material. So here you see a 3D printed object after it has been printed and a few weeks later. And then we printed this chair, our first chair, complete chair. And here it says a mushroom grower in Brabant, waiting to be full grown. And this is how it looked 2 weeks later. So we added sprout mushrooms. Not that it's really necessary, and not really necessary for the material to be structural, but it was for us a proof of concept and also as a poetic reflection of where the material comes from. And to show that it has fully grown and colonized the material and the product. And then you have to dry it. So here's our second stool, and already dried. And then it becomes durable, structural, and you can actually use it. So you can actually sit on this stool and use it as a functional object. So we have the technology available, and we're using it at our own studio, and everybody can use this technology at home. And also the mushroom we apply is already around us in our natural ecosystem. And besides that, we need these makers, this maker network. So this is a map from 3D Hubs. It's also a Dutch initiative. And they started with this website where you can upload your own design or an existing design and find local makers around you where you can collect it. And this network is already so dense that we can already collect our designs by foot and by bike around our studio. And it's just 1.5 years of existence. And most of these people, as the makers, use already these bioplastics, but all, as stated previously, coming from either the States or Asia. So we want to do, if we can embrace and use only these local resources, then we wouldn't need these centralized fabrication anymore and have to ship all these goods around our globe, but can make anything we want on spot. So now we have made products, functional products, such as a stool and a chair. And we're now cooperating with a Dutch company who is working on a printer reaching over 2.5 meters high. And they're actually, it's for home purposes, for like individuals and makers. So now we can think of architecture. And if you would bring this further, imagine how our cities would look like. So by embracing all these local makers and convincing them that we can use our own resources as a material and bring this even further towards our future, and that decentralized fabrication is already a fact but will become more present in our environment, and that we will make use of that, then our cities wouldn't look like this, and our waste would be absorbed through production. And on the other end, that all the disposed products we leave behind will, instead of pollute, just nourish and even fertilize our environment. So I hope that through embracing these new technologies, we can restore our natural balance. Thank you.
Thank you, Eric.